Hello and welcome to Astronomy Daily, your go-to podcast for the latest discoveries and developments in the cosmos. I'm your host, Anna, and we've got a great lineup of space news for you today. Coming up, we'll blast off with details of Blue Origin's latest achievement. Then, prepare to have your mind blown as we dive into groundbreaking black hole images that are the sharpest ever captured from Earth. We'll also explore the spectacular Aurora Displays that lit up skies across North America and beyond. And finally, we'll journey to the mysterious world of Titan as we look ahead to NASA's fascinating Dragonfly mission. So strap in and prepare for liftoff as we explore today's top stories from across the universe. Blue Origin has once again reached for the stars with their new Shepard vehicle, successfully completing their 12th crewed suborbital mission. The spacecraft carried a full complement of space tourists to the edge of our atmosphere, where they experienced the breathtaking views of our planet and the unforgettable sensation of weightlessness. This latest flight represents another milestone for Jeff Bezos' space company as they continue to establish themselves as leaders in the commercial space tourism industry. The new Shepard vehicle, named after Mercury astronaut Alan Shepard, follows a fully autonomous flight profile, carrying passengers in a capsule that detaches from its booster rocket before both components return separately to Earth. The reusable nature of New Shepard continues to demonstrate Blue Origin's commitment to more sustainable space travel, with the booster making a controlled, powered landing while the passenger capsule gently descends under parachutes. This mission further cements Blue Origin's growing track record of reliable suborbital flights, providing more civilians the rare opportunity to experience the overview effect, that profound shift in perspective that astronauts describe when seeing Earth from space for the first time. Now, this next story is pretty cool. In a major breakthrough for astronomy, scientists using the Event Horizon Telescope have captured the sharpest images ever of distant black holes from Earth. These remarkable new observations employed light at a frequency of 345 gigahertz, allowing researchers to peer deeper into the regions surrounding black holes with unprecedented clarity. This achievement represents a significant leap forward from their previous work at 230 gigahertz, with the shorter wavelength providing approximately 50% sharper resolution, around 14 microarc seconds. To put this in perspective, that's like being able to see a donut on the surface of the moon from Earth. The Event Horizon Telescope isn't a single instrument, but rather a global network of radio telescopes working in perfect synchronization. Using a powerful technique called very long baseline interferometry, scientists effectively created a virtual telescope the size of our planet. By combining signals from observatories scattered across Earth, they've achieved imaging capabilities far beyond what any single telescope could accomplish. Among the most studied targets are the supermassive black hole at the center of Galaxy M87 and Sagittarius A star, the black hole at the heart of our own Milky Way. With this enhanced resolution, researchers can now observe how light bends near these cosmic giants with remarkable detail, potentially revealing subtle behaviors that were previously invisible. The technical challenges involved were immense. At 345 gigahertz, atmospheric water vapor heavily absorbs radio waves, significantly weakening signals from distant black holes. To overcome this, the EHT team expanded their bandwidth and carefully selected high-altitude observation sites like the Atacama Large Submillimeter Array in Chile and the Submillimeter Array in Hawaii, where atmospheric interference is minimized. This advancement opens exciting new possibilities. Scientists can now study polarized light around black holes with greater precision, providing insights into their magnetic environments. The reduced effects of Faraday rotation, a phenomenon that alters light's electric field orientation, allows for clearer observations of magnetic field structures. Perhaps most thrilling is the potential to create time-lapse movies of black hole environments, showing material moving around the event horizon in near real time. For Sagittarius, a star, which has a dynamic timescale of about 200 seconds, simultaneous observations at multiple wavelengths could soon allow scientists to watch the cosmic dance of matter as it spirals toward the point of no return. This groundbreaking advancement in black hole imaging technology is set to revolutionize our understanding of these cosmic giants. With the successful 345 gigahertz observations, scientists are now on the cusp of creating something truly remarkable. time-lapse movies of black hole environments that would show us the dynamic nature of these extreme regions in unprecedented detail. For MADI 7's black hole, which evolves over a longer period of about 3 days, researchers could combine images collected over consecutive observation sessions to construct detailed visualizations of its active surroundings. These time-lapse sequences would reveal how matter behaves as it approaches the event horizon, potentially showing the formation and evolution of jets that extend thousands of light years into space. Beyond the well-known black holes at M87 and Sagittarius A star, the improved resolution enables detailed studies of active galactic nuclei jets with unprecedented precision. Researchers can now investigate phenomena like limb brightening, where jets appear brighter near their edges, and study how these massive energy beams form and accelerate across vast cosmic distances. Perhaps most exciting is the potential for multi-frequency synthesis, a technique that combines data from different frequencies to map black hole environments in exquisite detail over time. For our galaxy's central black hole, this could provide real-time glimpses into its turbulent surroundings, capturing moment-by-moment changes near the event horizon. Did you happen to see this? Earth has been putting on quite a show lately. A powerful coronal mass ejection struck our planet head-on in the early hours of June 1, triggering one of the most spectacular aurora displays in recent memory. The CME originated from an M8.2 class solar flare that erupted on May 30 and raced toward Earth at a staggering speed of nearly 1,938 kilometers per second. That's about 4.3 million miles per hour. When this massive burst of solar energy collided with Earth's magnetic field, it triggered what scientists classify as a severe G4 geomagnetic storm. This intense disturbance in our planet's magnetosphere created breathtaking auroras that were visible much farther south than usual, delighting skygazers across North America. The severity of this particular storm meant that aurora chasers were treated to spectacular displays, even in regions where such sightings are extremely rare. Terry Griffin captured beautiful aurora pillars in St. George, Kansas, noting that the white pillars were strikingly visible to the naked eye. In Cheyenne, Wyoming, skywatchers reported brilliant curtains of green and purple light dancing across the night sky. Perhaps most remarkable were the sightings from places like Farmington, New Mexico, where photographer Derek Wilson captured a stunning time-lapse of the northern lights. Wilson explained that visible auroras this far south are such a rare occurrence that he knew he had to get far from city lights when he saw the solar storm data. Most astonishingly, the light show was confirmed as visible on webcams as far south as San Diego, California, an extremely unusual occurrence that highlights just how powerful this G-force storm truly was. The Southern Hemisphere wasn't left out of this extraordinary light show. Skywatchers in New Zealand were treated to spectacular displays of the Aurora Australis, with vibrant red and pink hues illuminating night skies. The crimson and magenta hues that dominated many Southern Hemisphere sightings created an almost otherworldly atmosphere, distinctly different from the predominantly green curtains often seen in the north. In Australia, the Aurora Australis made a dramatic appearance over Victoria. The aurora was particularly impressive over Tasmania, with observers in Queenstown reporting some of the most vibrant displays. The rugged landscape provided a striking foreground to the cosmic light show, with red and pink aurora reflections visible in the still waters of lakes and bays across the region. What makes these sightings especially remarkable is their rarity. While northern lights are occasionally visible in the northern United States, seeing auroras from places like San Diego or Central Australia is extraordinarily uncommon, requiring exceptionally powerful geomagnetic storms like this G4 event. Now, let's turn our attention to a mission that will take us to one of the most fascinating worlds in our solar system. NASA is preparing to launch the Dragonfly mission to Saturn's moon Titan in July 2028, using a SpaceX Falcon Heavy rocket to send this revolutionary spacecraft on its 6-year journey. Titan is unlike any world we've explored before. It's the only moon in our solar system with a thick atmosphere, and its surface is dotted with methane rivers, lakes, and seas. This methane-rich environment has scientists excited because they believe Titan resembles what Earth may have looked like billions of years ago, before life transformed our planet's chemistry. What makes Dragonfly truly revolutionary is its design. Rather than a traditional rover, NASA has created a nuclear-powered rotorcraft, essentially a science drone, that can fly from location to location across Titan's surface. This mobility will allow it to cover hundreds of kilometers during its mission, exploring diverse landscapes that would be impossible to reach with a wheeled vehicle. The principal investigator, Zibby Turtle from Johns Hopkins Applied Physics Laboratory, explains that Dragonfly isn't searching for current life on Titan. Instead, it's investigating the chemical processes that might have preceded life on Earth. Since Titan is so cold, about 144 degrees Celsius below zero, any chemical reactions occur much more slowly than they would on Earth, effectively preserving evidence of prebiotic chemistry. One of Dragonfly's prime destinations is Selk Crater, a massive 90-kilometer-wide impact site. Scientists believe this ancient asteroid impact may have temporarily melted Titan's icy crust, creating a warm pool of liquid water mixed with organic compounds, essentially a prebiotic soup, similar to what might have spawned life on early Earth. By studying Titan, scientists hope to answer fundamental questions about how life begins. Is the path from chemistry to biology universal, following the same pattern everywhere? Or was Earth's development of life a cosmic coincidence? It's essentially a long-running chemical experiment, explains Sarah Horst, a Dragonfly co-investigator. That's why Titan is exciting. It's a natural version of our origin of life experiments, except it's been running much longer and on a planetary scale. Well, what an incredible journey around our cosmic neighborhood we've taken today. From witnessing Blue Origin's continued progress in commercial spaceflight to marveling at the sharpest black hole images ever captured from Earth. This has been Anna, hosting Astronomy Daily. If you'd like to keep up with all the latest space and astronomy news, visit our website at astronomydaily.io, where our newsfeed updates constantly. You can also follow us on social media by searching for Astro Daily Pod on Facebook, X, YouTube, YouTube Music, Instagram, Tumblr, and TikTok. Until next time, keep looking up.